my name is Rado Meyer, and welcome to a special extended edition of This Week in Android Development, featuring what's new in Android 4.3. Last week was a big one for Android with the release of the newest model Nexus 7. Measuring almost 2mm thinner and 50 grams lighter than its predecessor, it also features surround sound 5.1, front and rear facing cameras, a 1.5 GHz processor, 2 GB of memory, and a 1920 by 1200 resolution display. All this, and it confers a +3 to both public speaking and asking app girls. So if your apps aren't optimized for tablets, now's a good time to get started. But the real news for developers is the release of Android 4.3. In addition to the inclusion of even more butter, it includes support for restricted profiles, OpenGL ES3, Bluetooth Low Energy, and improvements to media, accessibility, and performance analysis. Let's take a closer look at some of these new APIs. Restricted Profiles builds on the multi-user functionality introduced in Android 4.1, allowing you to create sub-profiles that include system-wide and app-specific restrictions. That means your app can declare restriction entries including Boolean flags, choices, and multi-select choices, like this single-choice restriction entry, each of which can specify ways that your app's functionality could potentially be restricted. Your app will then appear in these system settings, where each of these restrictions you defined will be available to the device owner. They can select their preferences for your app for each of their restricted users. To apply those preferences to your app at runtime, simply check for a bundle of restriction settings associated with your app by querying the user manager when your app resumes, as shown in this code snippet. You can find out more about supporting restricted profiles from Rich Heineman's DevByte. Also new to Android 4.3 is platform support for Bluetooth Low Energy. BLE support allows you to build apps that interact with the latest generation of small, low-power devices and sensors that use Bluetooth smart technology to communicate. The BLE APIs use this workflow to interact with supported devices. You start by scanning for nearby devices, then manage connections, discover available services, and query and monitor characteristics provided by connected devices. You start by scanning for BLE devices, calling start LScan on the phone's Bluetooth adapter. The scan results are reported using this LScan callback that reports any detected devices, a received signal strength indication, and the advertisement data describing the services available from that device. You can then connect to that device using its GATT server, using the call connect GATT method, implementing the Bluetooth GATT callback to receive connection results and monitor the available services and characteristics. You can then read and write those sensor values and request notifications whenever a particular characteristic changes. Your app can work as either a client or a server and can transmit and receive data in either mode. The APIs are generic, so you'll be able to interact with a variety of devices including proximity tags, watches, fitness meters, game controllers, remote controls, and help devices. For more details on Bluetooth Low Energy and using these APIs in your app, check out this DevByte from our BLE expert Fred Chung. We've also introduced Java interfaces and native support for OpenGL ES3, so games and other apps with high-performance 2D and 3D graphics are now fully supported by the underlying graphics hardware. OpenGL ES3 includes many improvements, including these, that support the creation and complex but efficient graphics that work across a range of devices using a single texture compression format. There are also a number of enhancements to Android's media stack, starting with a modular DRM framework that makes it easy to integrate DRM into your preferred streaming protocols, such as MPEG-Dash. The new Media DRM class is a modular solution that separates DRM from media playback, so, for example, you could play back Widevine encrypted content without having to use the Widevine media format. The Media DRM APIs should be used in conjunction with the Media Codec APIs that were introduced in Android 4.1, including Media Codec for encoding and decoding your content, Media Crypto for handling encrypted content, and Media Extractor for extracting and demuxing your content. Support for VP8 encoding is also now available as framework and native APIs for a range of formats. The APIs include support for setting target bitrate, rate control, selecting frame rates, token partitioning, area resilience, reconstruction, and loop filters. Back in Android 4.1, the Media Codec class introduced support for low-level encoding and decoding of media, but it required that it be provided as a byte buffer array. In Android 4.3, you can use a surface as the input to an encoder, so you can encode input directly from an existing video file or using frames generated from OpenGL ES. To use a surface as the input to an encoder, call configure on your Media Codec object, followed by call create input surface to receive the surface upon which you can stream your media. To begin encoding, call start on the media codec, and when done, call signal end of input stream to terminate the encoding before releasing the surface. The Media Muxer class enables multiplexing between an audio stream and a video stream. It's designed to work primarily with media codec, so you can perform video processing using media codec and then save the output to an MP4 file using the Media Muxer. The Media Muxer can also be used in combination with Media Extractor to perform media editing without the need to encode or decode. Currently, MP4 is the only supported output format, and the Media Muxer supports only one audio stream and one video stream at a time. The first Jelly Bean release allowed media players to offer playback controls from remote control clients, like the lock screen, ongoing notifications, and Bluetooth remotes. This was all done using the Remote Control Client API. Now, these applications can also display playback progress and handle jumping to a specific playback position via scrubbing. If you're already using the Remote Control Client APIs, then you can add support for scrubbing by enabling the flag key media position update using the set transport controls flags method on the Remote Control Client. And this is going to make the scrubber visible. Then, implementing both an onGet playback position listener, overriding the onGet playback position method to return the current position of your media, and an onPlayback position update listener with an overridden onPlayback position update method to listen for a new time code when the user scrubs the playback using the Remote Control UI. With these interfaces defined, you can then set them on your Remote Control Client by calling set onGet playback position listener and set playback position update listener. A new UI automation framework uses the Accessibility Service APIs to support tests that interact with the device's UI by inspecting the screen content and injecting arbitrary keyboard and touch events. You can also perform system UI actions like hitting the back button, rotating the screen, and even taking screenshots. Best of all, the UI automation APIs work across application boundaries. To get an instance of the UI automation, call instrumentation.getUIAutomation within your instrumentation test case. You can then perform tests by creating events and injecting them into the message loop and confirm the results by introspecting UI elements. You do this by obtaining the root accessibility node of the UI and searching for the screen element you want to inspect, either by name or by ID. Execute your tests using the ADB AM instrument command, specifying the -W flag, package name, and test runner. Next up, the systrace tool has been improved to make it easy to provide more ways to profile the performance of your app. You can now collect trace data from hardware modules, kernel functions, the Dalvik VM, including garbage collection, resource loading, and more. Android 4.3 also introduces the trace class with the new static methods begin section and end section, which allow you to define specific parts of your code to include in systrace reports. So you can get a much more detailed analysis of where slowdown occurs within your app. There are also new developer options to help you analyze performance and spot rendering issues. The Profile GPU rendering option lets you visualize your app's effective frame rate on screen. You can choose to display profiling data as on-screen bar or line graphs, with colors indicating time spent creating drawing commands, blue, issuing the commands, orange, and waiting for the commands to complete, in yellow. The on-screen graphs are updated continuously, showing a graph for each visible activity, as well as the navigation bar and notification bar. A green line highlights the 60 millisecond threshold for rendering operations, so you can see your app's effective frame rate relative to a 60 FPS goal. There are also improvements to internationalization, including new utilities and APIs for creating better RTL strings and pseudo-locales to make it easy to test your app's localization. Accessibility services can now observe and filter key events so they can handle keyboard shortcuts or provide navigation in parity with gesture-based input. And apps can now define the exit and entry animation types used on a window when the device is rotated. You can set window properties to enable jump cut, crossfade, or standard Windows rotation. Look for more information on changes to the UI, including those animation changes, from a chat near you. Just in time for Android 4.3, the Support Package Action Bar API now, at last, is available. Find out all about how to integrate this critical piece of the Android design language into your app from this dev bite from our very own Chris Baines. When we weren't busy launching new Jelly Bean flavors, we were busy in our studio. Ankur is releasing the fourth part of his 5-part series on making apps beautiful, this time looking at performance tuning. Chet, meantime, returns with the highly anticipated second part on his series on anticipation. And on the App Clinic last week, I used Cricket apps as an excuse to design my own version of the perfect sports tracking app. My artistic skills are roughly on a par to the Australian top order's batting skills, so I devoted most of my session to strategies for minimising latency while maximising battery efficiency. If your app needs frequent updates but you don't want to drain the battery, check this one out. Our design advocates will be taking my amateur mocks and turning them into something more inspirational on tomorrow's episode of Android Design in Action. As always, you can go to developers.google.com/live/Android to see what we've got planned for ADL this coming week. The release of Android 4.3 also saw a flood of new and improved apps to Google Play, including Beauty and the Beast with restricted profile support, a Runtastic update that supports Bluetooth Low Energy, Netflix updated to provide 1080p HD video, and games such as Galaxy on Fire 2, Monster Shooter 2, Prince of Persia, The Shadow and the Flame, and Riptide GP2 from Vector Unit. We'll be back next week for more of what's new in Android development. In the meantime, that's all for our special What's New in Android 4.3 edition. Thanks for watching, and remember that these sounds fall into my mind.